this is section 1.6, and we've already done some parts of this section. This is where we were working with expressions. So I'm going to go over some of that we've done already, just to review. So let's see here. What we looked at before was how do you find the value of an expression? Now, an expression is something that contains variables. So for example, something like this. We might ask what the value of this is, which seems kind of crazy because, well, okay, there's numbers, but we can't add anything together. We don't know what x is. Now remember, when a number is next to a variable, it means 3 times x in this case, or that number times that variable. So what we might ask is, well, let x equal 4. Like with formulas and variables, what will happen is, or in expressions, we'll have to come up with the number for the variable on our own. That's usually what happens. This is different from equations where we're going to solve for a variable, where we discover its value. In this case, though, we're going to just give it a value and then see what that does to the value of the expression. So 3x plus 2 becomes 3 times 4 plus 2. Or 12 plus 2, or 14. And there we go. Now, let's say we do something else. Let's let x be 0. We have 3 times 0 plus 2. 0 plus 2, or 2. And that's it. So as we change the value of x, we're usually going to be changing the value of the expression, though not always. For example, let's say we have this. Let's say x is -2. Well, in this case, we'll have 5 times -2 squared. And keep in mind, since the negative is inside the parentheses, we're going to square that negative with the 2. So you have -2 times -2. And then we're going to subtract 3. Now that's important because -2 squared is -2 times -2. Negative times negative is +4. This is different from this. We apply, in this case, this negative is free to be on its own. We're just going to square the 2 to get 4. We get -4. It's just sort of one of those interesting notation things to point out. Anyway, let's get back to this problem. So this is a multiplication sign here. So we're going to get 5 times 4 minus 3, 20 minus 3, or 17. Now, let's say we let x be +2. So we had it -2. Let's let it be +2, and this is what happens. So we get 5 times 2 squared minus 3, or 5 times 4 minus 3. 20 minus 3, and again we get 17. So sometimes, even with different numbers, the expression will have the same value as some other value for x, when it has some other value for x. A little more trickier one. Let's say you have 2 variables, and we let x equal 2 and y equal 4. Well, replace x with 2, replace y with 4. Remembering this is 3 times x. So we'll get 3 times 2 plus 4 plus 1. And again, going left to right. There we go, and making sure we do the multiplication first. And that's expressions. So we've looked at this before. Now what's different in this section, we're going to talk about combining like terms. We have to talk about what terms are. So a term, it's basically numbers and variables multiplied together. Numbers and variables multiplied together. So 3 times x, 3x, that's a term. 4 times x times y, number, couple variables multiplied together. That's also a term. And then, let's see here, 2x squared y, a number, 2 x's and a y, all multiplied together. So these are examples of terms. And then there's something called a constant term. A number by itself is a constant term. Now, a variable by itself is also a term, but that's not a constant term. And you don't always have to have numbers with the variables. This would also be a term. But each of these are examples of terms. And this is a constant term. And typically with terms, at least in this section, they're usually or often separated by plus or minus. For our purposes, when we see plus or minus, they're going to be separating terms. So for example, this has 1, 2, 3 terms. Or something like this. Let me change this number here. Say it's 4. This has 2 terms. Now, terms, you can roughly break them up into 2 parts. So if we take something like this, this here is the variable part. And this is called the coefficient. And the way this works, we say 2 terms are like terms. This is when they have the exact same variable part. They have the exact same variable part. The coefficient doesn't matter. They can have different coefficients. This can change. That's perfectly fine. But if they're like terms, this has to be exactly the same. So that means same variables. And then the same exponents on the same variables. Same variables, same exponents on the same variables. So for example, 7x squared, xy squared, I'm sorry. This is a like term, same type of term as this. They're a type xy squared. So they have the exact same variable type. An x and an x, a y and a y, and there's a square on the y, square on the y. Nothing on the x, well, technically an invisible 1, and an invisible 1 here on the x. So the variables match, the exponents and where they're located match, means same like terms. So let me do some examples. Let's say we want to match the like term for this. And these are the choices we're given. Ooh, that's a rough coefficient. We'll go with something a little friendlier. XY. So we want to circle the like term, this term that's the same type as this. And you see all these 8s, and it's like, okay, that seems to be kind of cluing us in, but it isn't. The coefficient, the number in front, doesn't matter. So if we look at this, it's a type XY. It's the variable part we look at. This is a type X. This is a type Y. This is a type X squared Y. So type X, type Y, type X squared Y. I haven't found one of these yet. Type XY squared. And here we go. Type XY. So because this type matches that type, this is the like term. And that's how we can tell. I'll do another example. Negative 2x squared y. Well, looking at the variable, this is a type x squared y. So if these are our choices, well, first off, this is a type constant. There is no variable part. So I'm going to put type C for constant. This is a type XY. Again, it's not x squared y. Type XY squared, I mean, it seems close, but 2's in the wrong place. It needs to be on the x and not the y, because we have an x squared y. But this one, we've got it. Type XY squared, type XY squared. All right. So that's how we can identify types. Now we're going to look at combining these terms. And the way we do that is we count them up. Now, to count these up, let's say we have something like this. Now, we can rewrite this, because remember, multiplication. This is 2 times x, 3 times x. Multiplication is repeated addition. So this is x plus x plus x plus x plus x. And how many x's do we have here? Well, we have 5 x's. So we can just rewrite this as 5x because we're adding x up. Well, there's 5 x's we're adding up. Now this could get a little tedious, so there's a shortcut. we can just add the coefficients. Maybe it saves a little bit of time. You could probably skip this step. Okay, 2x plus 3x is 5x. Now, important thing to note here, I'm only combining like terms. I'm not combining different terms, and I'll talk about that at the end. So let's say we have this. We want to combine like terms. Well, we have two types. Type X. So we'll combine the type X's. And then we have type Y. We're going to combine the type Y's. So what we'll get, we can kind of prepare these for being combined, group them together. Very common thing. 4x plus 6x, that's 4 plus 6x. And again, I'm taking this extra step here. You don't have to do that. You could just say 4x plus 6x is 10x. And this will be 3 minus a single y. Again, keep in mind when variables are by themselves, there's an invisible 1 in front of that variable. And so we get 10x plus 2y. And that's it. All right. And so let's say we have something like this. Well, first off, we want to get rid of these parentheses. So we can do that by distributing. So we're going to distribute the number. We'll distribute the minus. So 2 times 2x plus 2 times 1. Again, this 2 gets distributed to both of these terms. Same with the minus. Minus x. And then minus goes to the 4, minus 4. We still have the plus x here. 4x plus 2 minus x minus 4 plus x. Excuse me. So we can combine terms. So we'll kind of put everything together. Here are the x terms. And then here are the constant terms. The 2 and the minus 4. These 4 minus 1 plus 1 x, and then 2 minus 4 is negative 2. 4 minus 1 plus 1, well, that's just going to be 4x plus minus 2, or 4x minus 2. And that's it. Let's see. So I do want to go over why we don't combine unlike terms. So let's say we have this. Now remember, we gave this expression or something like it a value. We choose a number for x, we choose a number for y. So for example, let x equal 2, y equal 4. So we get 3 times 2 plus 4, or 6 plus 4, or 10. Now, there's a problem, though, if we allow ourselves to combine the 3x with the y. So this is the correct answer when x is 2 and y is 4. Now let's say, though, let's let y act like it's an x. Now, the idea here is x and y are free to be two different numbers. But if y is just going to be like another x, well, then y doesn't get to be its own number. So our 3x plus y now becomes 3 plus x, and so we get 4x. And now if we let x be 2 and y be 4, we have 4 times 2, but there's no y. It disappeared into the x term. And so we get 8. Oh, I'm not going to box it. I'll circle it. But this isn't correct. We know that for this expression, when x is 2 and y is 4, we should get 10. So if we let the x's absorb the y as if it's an x, then well, we lose that y. We don't get to choose an independent value for it. Now, same thing, if we let the x's be absorbed like their y's. Well, in that case, we have 3x plus y, but the x will treat like it's a y. And so we end up getting 4y. And then we make our substitution, x is 2 as y is 4, but now the x has disappeared. It's been absorbed into the y's. And so we get 4 times 4, or 16. And again, that's not the correct answer. We need to make sure x exists so it can receive whatever particular number it's going to get, and y will exist so it could get a different number if we want it to. Now, by coincidence, you could choose x and y to be the same number, and that's fine. But here you do have the option for them to be different numbers. And if you allow them to be absorbed by each other, you don't have that option anymore. So that's why we don't consider these like terms. If we keep them as different terms, it allows us to put different numbers into the expression. Well, that's it. If you have any questions, let me know.